Hey y'all, welcome to Algebra 2 Saxon, 3rd edition. Hope you have a good year of this stuff. Anyway, a couple things I just wanted to talk about. I've been doing Saxon math for about 20 years at this point in 2021, and definitely I'm going to start with lesson 1, but you definitely want to go back and review and do all the problems for problem sets A and B before you start this. So if you haven't done that yet, stop it and go back to A and B and do those two first. Take a couple of days to do that and get that geometry stuff down. It's just review mostly, but you know, there are some things in geometry that are you'll want to make sure you know before you go on. But this year, make sure that you have definitely the 3rd edition of Saxon math. The difference between the 3rd edition and the 2nd edition is that if you open up your book and look at the problem sets, there are numbers in parentheses by every problem in every problem set, which shows you where to go if you forget how to do that type of problem. So I definitely recommend doing something like this, keeping your notes like in a separate notebook, like here's your paper, and let's say we're on lesson 37 or something like that. Do something like that, because a lot of times I will have examples for you how to do those, and what I'll do is have different things that are not in the book, shortcuts, and sometimes little lists of this step, and this step, and then an example. Then when you're, let's say, on some problem, and it's like you forget how to do that, and it says by the problem, it'll say a little 37 in the problem set, you can turn back to your notes, which you should keep in order in a loose leaf notebook, so you can not punch holes, but you can put it in there and take it out and not rip it to shreds. But you can look at this and go, okay, oh yeah, I need to look back at, the steps are this, and so on. So the Saxon method is repetition, and each problem set should take you roughly the same amount of time to complete, because there's about an equal amount of older problems and newer problems and so on. So anyway, you definitely want to keep this regular. Do your problem sets regularly. Don't skip out, and don't do just the odds, just the evens. That's a terrible way of doing Saxon math. These are very specially formulated to get you to do certain problem types. If you ever find yourself where you go, oh, I can't do, I have to do this over 2 days because of my time or whatever, go ahead and do the odds one day, like 1 through 29, and then the next day do the same problem set and 2 through 30, the evens. Don't do 1 through 15 and then 16 through 30, because what happens is, let's say problems 17 and 18, well, they'll be the same type of problem. So if you do 17 and 18 in one day, you'll get practice on that type of problem, 2 of those in one day, and then the next day you'll get none, because you've already done 1 through 15 or whatever. So do it odds and evens if you do it that way, but make sure you do every problem and every problem set. And if you're going through and there's certain types you have a problem with, even months into it, you can get some help or a tutor or whatever, but you will have done a great number of these right. And you'll find that you're in lesson, 90 or whatever, and you're doing 30 problems, every single problem set. And let's say you got, 25 out of 30 right. Well, that's pretty doggone good. That's 83% of potentially 90 problem sets, which is like 400 pages worth. So that's pretty good. And so keep working at it. Do the best you can, and look at these videos and watch them as many times as you want. If you don't want to watch them a lot of times, make MP3s out of them and just put them in your Spotify, so they can just lull you to sleep at bedtime if you're having a problem. Anyway, welcome aboard. Anyway, let's talk about polygons first. Polygon means many-sided, and polygon defined is simple, which means the lines don't cross. It's flat. It's closed, which means the lines connect, all the lines, and the signs are line segments. Now, if you look on page, in the very front of your book, there's on page 19, there's some problems, or actually drawings. Why aren't these polygons? Well, this isn't simple, the lines cross. Another one, those lines to cross. This isn't closed because there's an opening right here to here. This has a curved side, so that's not a line segment, so they're not polygons. Types of polygons, there's a concave and a convex. A concave, let's do convex first. A convex polygon looks something like this, and the definition is that you can basically take 2 points on there anywhere inside that polygon, and you can connect those 2 points with a line, and the line won't be outside of the polygon anywhere. If it's concave, it could be something like this, and well, it's not very good drawing there. You're going to find I'm the worst artist on earth. You can connect these 2 dots and the line goes outside of the polygon. That's a concave polygon. A regular polygon has 2 characteristics. Regular means it has all the angle measurements are the same and the side lengths are the same. And there are examples of these. Look on the top of page 20, and there's a regular pentagon. You can tell the angles are all the same and the side lengths are all the same. There's a regular heptagon, and we've all seen a regular octagon, an 8-sided figure. And when the policeman pulls us over and tells us we ran a stop sign. And anyway, that's a regular octagon. Okay, triangles, let's knock around a few things about triangles. A right triangle is this. Well, pretend that's a right angle. It's a 90-degree angle. An acute triangle has an angle that is, I'm drawing angles and I should be drawing triangles. There we go. An acute triangle has an angle that is, all 3 angles actually are less than 90 degrees. An obtuse triangle is something like this, where it has one angle that's, let's say, more than 90 degrees. Equiangular is kind of like this, where all the angles are well, and they'll indicate it by this. You'll see little tick marks and things like that. Now an angle, this angle right here, the bigger an angle is, the larger the side is opposite it. So if this is a certain length because of this angle, well, if all the angles are the same angle measure, then that means all the sides across from them will be the same measure as well. And they'll put similar tick marks on sides that are congruent, and that's the fancy word for equal in geometry. So an isosceles triangle has at least 2 sides of the same length, and which corresponds to the angles across from those sides. Equilateral means all the sides are the same length. A scalene triangle is just kind of one that doesn't have any, anything that's the same. Let's say they'll mark it like this sometimes with the sides to indicate there's 1 and 2 and then 3 tick marks to show you that none of these, they're all different sizes. So, okay, and they'll give you examples like this, and they're an example of tick marks right there. And what they are telling you is 2 things here. Well, first off, this side length is the same thing as that side length. Now, a side length is made by the angle opposite it. So this angle here, how far open it is, opens up these sides and makes the length of the side across from it, okay? So if this side length here across from it gives us an angle of 50 degrees, or maybe I should say a 50-degree angle gives us that side length, that means that since this side length is the same as that, that means the opposite side over here is also 50 degrees. So we just found x. All right, well, since this is 50 and that's 50, that's a total of 100. And how many degrees are there inside every single triangle on Earth? Not sure about the other planets, but it's 180 degrees. So if these 2 are a total of 100, well, then y has to be 80. And by the way, here's a good SAT tip. If you're taking a standardized test, you can look at angle y, and if you have a bunch of choices, you know that this is not quite a 90-degree angle, it's a little less. So if the guess is somewhere between 75 or 80 or 85, choose that one, or at least you'll have a better chance of getting that one right. Okay, here's another one, find x and y. Well, let's take a look. Let's find x first. Well, this line here, since it goes from here to here, in other words, this is what this angle is. We can go from here all the way to there, and that covers the area of 2 right angles, which means this is 90 and that's 90, so the entire measure from here to here is 180 degrees. Well, since we've already taken care of 150 degrees, this angle right here has to be 180 minus 150, or 30 degrees. All right, and since that is 30 degrees, and we have this as 40 degrees, that's a total of 70 degrees, which means that we have 180 total. 180 minus 70 is 110, and that is the measure of angle y. All right, this is an equilateral triangle. Find D. And that's easy. There's D right there. Okay, next one. No, I'm just kidding. Okay. Well, if it's an equilateral triangle, that means the sides are the same lengths. if the sides are the same lengths, that means the angles that open up to make those sides are also the same measurement. So we have 180 degrees total in a triangle. If all three of those angles are the same, we're going to divide 180 by 3, which gets us 60 degrees for every single angle. 60, and then 60, and then 60. Okay? And since this is a straight line, or sometimes called a straight angle, from here all the way to here is 180 degrees. And that part is 60, which means D has to be 180 degrees minus 60, or 120 degrees. So there you go. All right. Transversals. Let's talk about this. Trans in Latin means across, transcontinental, transportation, and so on. And a transversal is a line that intersects parallel lines. Now, this thick kind of arrow indicates that these lines are parallel to each other. So whenever you see that, that's just not like a fancy arrow. That means that this line is parallel to that line, is parallel to that line. All right. Something interesting happens when you cut across parallel lines with a transversal, a long line that cuts across them. I mean, there are other examples too. There's P is a transversal of lines S, M, and N, and this time it shows P. These are perpendicular, and that is, of course, S, M, and N are parallel, but P is perpendicular to all those, and the symbol for perpendicular is this. Those two lines are perpendicular. Okay, something interesting happens with this, and what happens is this. You will get basically, let's say you have a degree, and we'll call it, I don't know, angle 1, and then angle 2, and then angle 3, and then angle 4. All right, what happens is, we'll call this angle 5, 6, 7, and 8, and then we'll call this 9, 10, 11, and 33. I never said I was consistent, so anyway. What will happen is, angle 1 will be the exact same measure as angle 5, which will be the same as angle 9. So in other words, the top right one will match each time. Also, the top left one. 2 will match 6, will match 10, and so on. And then, of course, obviously, 4 will match 8, will match 33, and then 3 will match 7, will match 11, and so on. Okay, and also, angles 2 and 4, you will find that since 1 and 4, if you add those together, they'll be 180 degrees. Also, if you add angles 1 and 2, they'll be 180 degrees. So since the only thing that's changed is angle 1, that leads us to conclude that angles 2 and 4 are exactly the same angles. These are called vertical angles, like this angle and that angle. And those are going to be congruent. All right, so let's do a couple of these here. Find A, B, and C. Well, first off, let's find A. It's sitting right next to a 60-degree angle. And again, from here to here is 180 degrees. So 60 plus what will give you 180? And the answer is 120. Okay. Now at this, this is the bottom right portion of this. We'll call this a little, this chunk down here, which means the bottom right, A, is 120, and this transversal is cutting across a parallel set of lines here, which means that B is going to be exactly the same measure as A, which will also be 120 degrees. And since we have that, well, we have two angles next to each other. Again, from this entire to there is going to be 180 degrees because it's a straight line, a straight angle, right? Since that's 120, then 120 plus what is 180? And of course, the answer is 60. Okay, and that's A, B, and C. All right. This is interesting too. When you have two lines or more that cut across transversals, transversals that cut across parallel lines, something interesting happens. Now let's say, for example, I don't know, this is an inch. I know it's not, but it's okay for our purposes. This is an inch, and this is, let's say, 2 inches. In other words, from here to here is 2 inches, and from here to here is 1 inch. Well, you'll find, and you can actually measure this yourself, it's really weird, that, let's say, for example, let's pretend that this was 3 inches. It's not, but let's pretend it is. What happens is these parallel lines turn these transversals into basically just equivalent fractions, is what they are. So they'll say something like, well, for example, this is 1 and that's 2, this is 3, this will be 6. If you actually measure it out with a ruler, it'll actually work. It's really weird. So in other words, this is like almost like saying 1/2, and this is like 3/6. So they'll be equivalent fractions of each other if you have these transversals cutting across these parallel lines. So for example, but they won't always be this, like these easy fractions, but you can set them up. In other words, you know how to do this, right? If you have two fractions, that's the same thing. And we can prove that these are equivalent fractions because we can cross multiply. So if you said 1 times 6, which is 6, that's going to be the exact same thing as 2 times 3. And that'll be correct. All right, so let's do one of these. And they show you that these are parallel, and these are two transversals, and these, which means these line segments are going to be proportional. So there isn't, you don't have to, your book does all these little, multiplying values and I'll forget all that stuff. Just make these into fractions. Make it as simple as possible, okay? So let's go 2 over 5, and that's going to equal 8/3 over x. Okay, that's an equivalent fraction. So we'll cross multiply. I always like to put my x's on the left. So 2 times x is 2x. And that's going to equal 5 times 8/3. Well, 5 times 8 is 40/3. Okay, so let's solve for x. We're just going to divide by 2. You could probably look at this immediately and say, well, 40 over 3 divided by 2 is 20 over 3, of course. But let's just pretend you didn't. We're going to divide by 2. We're going to divide by 2. That means we're going to multiply by 1 over 2, right? And we can go ahead and go, we can either go, that's going to be 40 over 6, which reduces to 20 over 3, or we can just go ahead and kind of knock that off. Go 2 into 40 goes 20 times. 20 times 1 over 3 times 1, 20/3. There we go. All right. Okay, let's go ahead and try the practice problems. Go ahead and do A and B. And then just go ahead and pause your computer or your video right now. Go ahead and do A and B and then unpause and we'll talk about it together. So, all right, pause it. Okay, A is 35 degrees, which means since this tick mark, this angle makes that length of side. Well, if it's the same as the other one, that means angle C is also 35. The total of 35 twice is 70. Which means this will be 180 minus 70 or 110 degrees. All right, B, find x and y. Well, first off, x is going to have to be 180 degrees. Of course, from here to here is 180 minus 145, which means x is going to have to be 35 degrees. So that's 35. That's 40. That gives you 75. Well, 180 minus 75 is 105. So there's your measurement for angle y. Okay, pause it again and try C and D and come back when you're finished. All right, well, let's find A, B, and C. A, again, from here to here is 180, which means 130 from 180 is 50 degrees. This will be a 50-degree angle. If this is the top right angle, and it's a transversal, these are parallel lines you see by the arrows, that means the top right is 50. So on this one, the top right is also 50. So C is also 50 degrees. Now the B is weird. We haven't seen this before. Okay, so let's look at this. We know that since this is 50 degrees, 180 minus 50 is 130. We know that's true. Also, we know that because the top left is 130, and of course, this is kind of like the top left of that chunk of the drawing. So we're gonna set an equation here. 2 times b is equal to 130. All right, we just divide by 2, and b is going to be 65. There we go. Okay, x, find x. We're just going to do exactly the same thing we did before. We're going to set up two fractions, equal fractions. That equals that. Okay, we'll go 3/4 over 6/5 equals 5/3 over x. There we go. Let's just cross multiply. So we have 3/4 times x equals 6/5 times 5/3. Good gravy. I'm going to go over here. Just remind myself, 6/5 times 5/3, that cancels. The 6 and the 3 cancel, you just get 2. So 3/4 x equals 2. To solve, we're going to multiply by the reciprocal, times 4/3, times 4/3, and x is going to be 8/3. Is that right? Let's check it, okay? We'll do 3/4 times 8/3 which is 2. All right, and we already did this and saw that it was 2, so we have just proved that we are right. Okay. All right, that is it for problem set or lesson 1. See you guys next time, and don't forget, get some notebook paper, loose leaf, and get it set up to where you're doing every single lesson like this and writing the problem set or the lesson right there so you can look at your notes. If in the future you have any problems or questions or whatever, you go back to your notes and do that. So thanks, blessings, see you guys pretty soon. Bye-bye.